Welcome to Get Your FRQ On. In this tutorial, I'm going to show you how to work with sequences on your graphing calculator. Sequences are kind of like functions, only you have to change the mode. So wherever your calculator allows you to change your mode, on this one it's up there. I'm going to click on that, and then down here where it says function and then parametric, polar, and SEQ, SEQ is short for sequence, I'm going to select sequence. Quit. And now my calculator is in sequence mode. Well, it doesn't look any different. It's going to look different as soon as I click on my function editor. So in your calculator, when you click on your function editor, you're going to see something very different. All right, I have different sequence types. Sequence n, which would be really an explicit sequence. It's just going to take whatever value n is as n increases. And then just evaluate the rule there, or you can go to what is really a recursive sequence. You can define the next term based on what's happening with the previous term, what that previous term is, or you can define a sequence that accounts for the two previous terms, right? So in this video, we're going to go through all three of these. So I'm going to start with just a regular sequence. N minimum generally doesn't matter. And then when I type in my rule, the variable that I'm using, n, because I'm in sequence mode, I just have to hit my variable key. Normally that's the same key I would type to get an x, but since I'm in sequence mode, it gives me an n. And so what I can do here is define this sequence. All right, is there a first term, or are you just using the n minimum of 1? If I go to table, the 10th term is 17, the 5th term is 7, the 4th term is 5. Generally, it's not going to apply the sequence when n is a decimal. So let's go to table set. Let's go to table start 1, and we'll go to auto. Go back to the table, and these are the different terms of the sequence. All right, now if I go back to this and I change this from a sequence to sequence n plus 1, which is now going to be recursive, the way I have to define this is a little bit different. I'm going to go 2, and then I need to refer back to this same sequence. So if you notice above my 7 here, there's a little u. That is this sequence, right? So I'm going to call back to this sequence, and then parentheses the previous term n. So I'm going to double the previous term and then subtract 3. And let's say that my previous term, if my n min is 1, let's just say my first term is 5. Right, now if I go to the sequence in the table, I get those outputs. Right, I can graph this, zoom out for just a bit, and you can see some of those terms of the sequence being graphed. If I go back, I'm going to go to a sequence which is defined in terms of the two previous terms, and then I'm going to go, the n plus second term is the sum of the nth term, and the n plus first term, which would be the two previous terms. And I'm going to set these both equal to 1. All right, now if I go to my table, 1, 1, 2, 3, 5, 8, 13, this should look pretty familiar if you are all familiar with the Fibonacci sequence. And so this is how you can work with functions that are really just sequences on your graphing calculator.